शुरू अल्लाह के नाम से जो बड़ा मेहरबान निहायत रहम वाला है।
Assalamu alaikum and welcome to all viewers. In today's lecture, we will discuss power and velocity. Before starting the lecture, make sure to subscribe to my channel and hit the bell icon and stay updated on future videos. Let's try to understand the concept of power by a simple example. Here in the picture, green dotted line on the road is the start point and the red dotted line on the road is the finish point. The shortest distance between these 2 points is displacement. Now you can see that we have 2 cars at the start point for a race. After the start signal, both cars start to move to the finish point. As a result, we saw that both did the same work while covering the same displacement. But the red car reached the finish point earlier than the orange car. So we can say that the red car has more power than the orange car. So by this simple example, we can define the power as the measure of the rate at which the work is being done, or the rate of doing work of a body is known as power. So we can write the expression for power as power is equal to work per unit time. So from here we can get the unit of the power. The unit of the work is joule and time is second. So the unit of power is joule per second. And as a unit of power is watt. And we can say that watt is equal to joules per second. The power will be 1 watt if the body does 1 joule of work in 1 second. Remember one thing, when the rate of doing work is different, then we introduce average power, which is the total amount of work done in total time. So we can write it as delta W over delta T. It is sometimes convenient to express power in terms of a constant force acting on an object moving at constant velocity. Let's see this animation. Here you can see that boat is moving with constant velocity. Why? Because the propeller of the motorboat is causing the water to exert a constant force on the boat at every instant of time. So we can define instantaneous power as the rate of doing work at any instant is called instantaneous power. Keep one thing in mind here, that when we will talk about the instant, that means we are putting a restriction or a limit which is delta T approaches to 0. So we can express this definition in terms of the equation as instantaneous power is equal to limit delta T approaches to 0 delta W over delta T. Here I am putting the value of work done equation, that is F dot delta D. Now question arises, why I place delta with this D rather than putting this delta with F as it is given in the equation over here. As we already have discussed that the scenario we have discussed, the boat scenario, the force is constant. So that is why I am not placing delta with this F. If I will place this delta with F, then the change in force is equal to 0, then we will not get any kind of result. So why delta with this D? Because we know that displacement is the shortest distance between 2 points, mean it is the difference between 2 points. That is why I am placing delta with this D. And now this delta D over delta T gives us the value that is known as velocity. So here we can also define the power, that the power is the dot product of force and velocity. So if I will open this equation, if I will open this dot product, then we know that I will place cos of theta. Let's talk about some important information regarding power and its unit. Watt is very small unit of power, commonly used in power of bulb and electric fan. Usually we use kilowatts. So 1 kilowatt is equal to 1000 watts. In British engineering system, the unit of power is called horsepower, and 1 horsepower is equal to 746 watts. The power of generating stations and that of grid stations is expressed in megawatts, and 1 megawatt is equal to 10 raised power 6 watts. Also, the commercial unit of work, that is electrical energy, is kilowatt hour. Now question arises here that if kilowatt hour is the unit of work which is electrical energy, then it is equal to how many joules? I will write the value of the prefix kilo, which is 1000, and the value of this watt in term of unit, that is joule per second, multiply, I will convert this hour into seconds. It will become 60 minutes multiplied by 60 seconds, it will become 3600 seconds. By cancelling out this nominator second with this denominator second and multiplying this 3600 with this 1000, the result will become 3600,000 joules. So converting it into scientific notation, the final result will become 3.6 multiple 10 to the power 6 joule. So we can say that 1 kilowatt hour is equal to 3.6 multiple 10 to the power 6 joules. So this was our today's lecture. If you learned something from this video, then hit the like button and share it with others. Also, do not forget to subscribe to the channel and hit the bell icon. Now we will meet in the next video with a new lecture. So take care of yourself. Allah Hafiz.